Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create ADSL dataset for a parallel arm study. So let's see what we'll be discussing in this video. So we'll be creating an ADSL program for a one period parallel arm study in which there are variables which are related or which are directly coming from SDTM demographics dataset and also the supplementary demographics domain, disposition domain and vital signs domain. So it includes baseline variables like for height and weight. It includes key date variables, the enrollment date, informed consent date, randomization date, treatment start date, treatment end date, end of study date, date last known to be alive, etc. It also includes treatment and study status variables EOT STT and EOS STT. So it includes creation of variables, grouping variables which are age group 1 and age group 1N. It includes treatment duration variable which is TRT DURD. This also includes derivation of subject level population flags like enrollment flag, randomization analysis flag and safety analysis flag. And it also includes derivation of treatment variables which are like TRT01P, 01PN, TRT01A and 01AN, etc. So if you are watching this video as the first video, and then you please note that in detail all the concepts involved in ADaM programming are kept in a playlist, and in most of the cases they are organized in a logical sequence. Similarly, we have a separate playlist for clinical SAS SDTM and also for TFLs. So I will leave the links for these playlists in the description of this video. Let's now move to the specification of our ADSL dataset that we are going to create. So here we have the specification. So we have the variable name, the variable label, and the type of the variable, whether it is character or numeric, and some general comment for the derivation of a particular variable in ADSL. So in ADSL, so the base dataset that will be used to create ADSL from SDTM is the demographics domain. So we know that in SDTM DM domain, so we'll have one record per subject ID. So the same structure is carried forward into analysis dataset, which is ADSL here. So here we will be making use of the information from demographics dataset and additional information from other SDTM datasets and create ADSL. So if we see, some of the variables are direct copies from demographics domain and some will involve additional derivation here. So now we'll quickly go through the derivation logics of given in the specification. So here if we see from study ID, it says copy from SDTM DM study ID. Similarly for U subject ID, site ID, age and age unit. So wherever the general comment is specifying it as DM dot this way, so it means that as per the convention given here, it is just a copy variable. So and next we have one variable called age group 1, which is a grouping variable. So here we are being asked to populate it using dm.age, which means the age variable from SDTM demographics domain. So we will have to use the value present in this variable and create this. So if the value in age variable is less than 60, then we are being asked to populate it as less than 60 years. And else if it is greater than or is equal to 60, then we are being asked to assign the text greater than or is equal to 60 years to age group 1 variable. Similarly, we have age group 1n, which is numeric version of age group 1. So here we were creating two values like less than 60 years and greater than or is equal to 60 years. So we are assigning a numeric value for age groups so that we can use it for sorting purpose in the TFLs. So here we are assigning a value of 1 when less, age group 1 is 60 less than 60 years, and assigning a value of 2 for greater than or is equal to 60 years. And then sex and race are copy variables from SDTM DM domain. And then we have race 1, race 2 and race SP, which is race other specify. So we know that in SDTM demographics domain, there are a certain standard set of variables. We cannot add any additional variables to the variables that are specified in the implementation guide or the SDTM model. So if we are collecting any information which is not part of the standard, which could not be mapped to the standard variables, we create supplementary domains, and we create a row for each of those supplementary questions in the subdomain. So here we are being asked to populate race 1, race 2 and race SP, so which is coming from supplementary demographics domain. So for race 1 we are being asked to populate it with the qnam race 1 and the value from qval. Similarly for race 2 and race SP. So these three variables are coming from supplementary demographics domain. And then we have population flags. We have safety population flag, complete population flag, randomization and enrolled. So now let us see the derivation provided for safety flag. So here it says populate as Y for the subjects with non-missing treatment started, which could be identified using the variable ADSL TRT SDT. So which means this variable is dependent on other variable in ADSL itself. So we have not seen the derivation of TRT SDT yet. So if you are trying to derive variables in sequence, so you have to make a note that there can be some variables which are dependent on other variables but which may appear somewhere down the line. So here if you are just focusing on SAFFL, so if we see it is dependent on ADSL TRT SDT. So let's take a quick look at TRT SDT. So how is it populated? So if we see ADSL TRT SDT is derived as ADSL.TR01 SDT. So we have further dependency on another variable within ADSL itself. So which means, we'll have to go and check the derivation logic for TR01 SDT. So here if we see for TR01 SDT, so it says populate using DM RFX STDTC. So which means, so indirectly our safety flag is dependent on dm.rfxstdtc. So whenever we are deriving a new variable, if we have dependencies, we have to make sure that we are going through the specification of all the dependencies, and also when writing the program, derive the variables which will be needed as input for other variables first, so that our process flow will be easy. So we have seen one example. So there can be other complex manipulations which will be required as for input for another variable. So here now let's go back to safety flag. So we'll have to first derive TRT SDT, or if some programmers will completely understand this logic. So they clearly know that ADSL TRT SDT is coming from ADSL TR01 SDT, which is indirectly coming from DM.RFXSTDTC. So they will make use of DM.RFXSTDTC directly when creating safety flag. Again, so in this case, so as it is kind of simple mapping, we'll be able to use DMRFXSTDTC, but there can be complex cases where you cannot directly go and use the value from the raw variable. So for that, what you need to do is derive that complete information first, and in the subsequent steps, make use of that variable or information for deriving the different analysis variable. So now let us move to the completers flag. So it says populate as Y for the subjects who completed the study. So the completers flag will be populated for the subject as Y for the subjects who completed the study, and we are also being provided with the condition which can be used to identify the subjects who completed the study. It says ds_scat is equal to end of study, which is coming from disposition dataset, and ds_decode is equal to completed. So for all the subjects who have a record with this condition, we will be populating it as Y. Otherwise, we will be populating it as N. And then we have randfl, which is randomized population flag. Here it says populate as Y for the subjects with non-missing randomization date, ADSL randt. Similar to what we have seen in safety flag. So this variable is dependent on other variable within ADSL itself. So for which the variable has not appeared before this one. So else populate as Y. So what we need to do is we need to try to understand the derivation or keep this variable ADSL randt available before creating randfl. Let's quickly see the derivation for randt. So here it says populate using ds_stdtc on the record where ds_decode is equal to randomized. So we first need to fetch the information which is present on this record where ds_decode is equal to randomized and create randt, and then make use of this information to create randfl. So this is how we will have to handle the interdependencies between one variable and the other variable within the same domain. So, and then we have enrollment flag. So it says populate as Y for the subjects with non-missing enrollment date, similar to what we have seen in randomization flag. So this is dependent on a second variable within ADSL, which is enrollment date. So for all the subjects who have this as non-missing, we are being asked to populate as Y. Otherwise, we are being asked to populate as N. And then we have ARM and actual ARM values, so which are direct copies from SDTM demographics domain. And then here we have TRT01P, which is planned treatment for period 01. So uh, we are being asked to populate it using the values from dm.arm. So if arm is equal to placebo, then we are being asked to set it to the text placebo. And then for if arm is equal to active, then we are being asked to set the text active. So otherwise set it to null. And then we are creating a numeric variant of plan treatment for period 1. So for which we are setting the value of 1 when the plan treatment is placebo. Otherwise when treatment is active, we are setting it a value of 2. And similarly, we are creating TRT01A and TRT01AN. So 01P is for planned and 01A is for actual. So which here, so planned variables we were creating from the planned arm variable of SDTM demographics. And for actual arm variable in ADSL, we are making use of the act arm variable value from SDTM demographics. So similar to planned arm, we are making use of actual arm. And then I think the derivation here should have been if act arm is equal to placebo and then placebo. Else if act arm is equal to active, then active. So similarly, we are creating a numeric variant of actual arm. So we are assigning a value of 1 when the again here the specification should have been TRT01A here also. I'll try to correct it post this video so that it will be live on the website. So here it will be TRT01A is equal to placebo, then set to 1. Else if TRT01A is equal to active, then we are setting it to 2. And for TRT SDT and TRT EDT, we are being asked to make use of other set of variables which are present in ADSL itself. So for 01 TRT SDT, it is 01 SDT, and TRT EDT, it is 01 EDT. So we will be seeing now the derivation for TR01 SDT and TR01 EDT. So for TR01 SDT, we are making use of RFXSTDTC, which is the exposure start date from demographics domain. And then 01 EDT, we are making use of the end date of exposure from SDTM demographics domain. And then we have end of study status variable, so which is used to capture whether a subject has completed, discontinued, or ongoing in the study. So here if we see, we are being asked to populate it using populate the end of status record, populate using the end of study status record in disposition data. So we are being given the filter condition which can be used to identify the end of study status record. So which is ds_scat is equal to end of study. So if ds decode on the end of study record is completed, then we are being asked to set the value of completed to end of study status. Else if ds decode is not null, then set to discontinued. So if the record is created and if the value is not completed and it has some other value other than completed, then we are being asked to populate it as discontinued, because we know that on the end of study status record and disposition data, so if the subject is completed, we will populate it with the value of completed. Otherwise we populate the DSD code with the reason why the subject is discontinued. So any other value other than completed internally indicates that the subject discontinued. So we are populating or making use of that to populate it as discontinued. And it says else if no record exists in disposition for end of study status, a subject is not screen failure, then set to ongoing. So if there is no record with end of study, so because in disposition we create a record when the subject reaches that stage of completion or discontinuation, but for ongoing subjects we do not expect a record in disposition dataset with the end of study dscat. So for such subjects we are being asked to populate it as ongoing, but only for subjects who are not screen failures. And then for EOSDT, so we are being asked to populate it with using the value from DSSTDT record where DSSCAT is equal to end of study. So here if we see, we are making use of the same record, end of study status record here for both EOS STT and EOS DT. So when reading the specification, we'll have to identify these kind of commonalities so that we do not repeat the same logic for deriving different variables. So here if we just subset the record for a DSS cat is equal to end of study, and if we can make use of DSD code on this record to create EOS STT, and DSSTTTC from the same record could be used to create EOS DT. So this again comes with experience, but we'll have to just keep an eye on where a single source record is being used for different variables. So again, so we have DCS reason, the reason for discontinuation from study. So again, it says populate using DSD code from the end of study status record in disposition dataset. So again, DSSCAT is equal to end of study and DSD code is not completed. So if we see for these three variables, a single source record where DSSCAT is equal to end of study is being used. So for DSD code can be used to uh, populate USSTT, DCS reads, and DSSTDTC from the same record can be used for EOSTT. So keep an eye on the where same source record but different variables are used for different variables in ADaM dataset. And then we have similarly these are the variables which we have seen were three for end of study. Similar, we have three parallel variables for end of treatment, which is EOT STT, DCT REAS. So we do not have EOT DT, but if needed, we can create EOT DT also using the treatment completion status from disposition. So EOT STT, we are being asked to use the val record which has DSSCAT is equal to end of treatment. And then we are creating DCT REAS as DSD code where from the end of treatment record itself where the DSD code is not completed, because we are populating the status as discontinued, and the reason why they have discontinued is captured in this second variable DCT REAS. T for treatment, S for study here, DCS REAS and DCT REAS. So and then we have some key date variables RFICDT, enrollment date, randomization date last known to be alive. So informed consent, we are being asked to populate it with the value from DM RFICDTC after converting the date portion to numeric version. Similarly, enrollment date of enrollment, we are being asked to use the value from disposition dataset, which is DSSTDTC, on the record where DS term is equal to enrolled. So we know that there could be multiple records within disposition. So when writing the specification, it has to be clear that which record has to be used. So we are being given a condition that where DS term is equal to enroll has to be used. So we will get one record with per subject with this condition. On that record, we will have to make use of DSSTDT, then create enrollment date. And similarly, we have randomization date. So here again, we are making use of disposition dataset, but here we are making use of the record which has the value of DS decode is equal to randomized. And then we are creating the variable called date last known to be alive. So here we are being asked to make use of the variable called RFPENDTC from SDTM demographics domain. Some variables are coming from disposition, other variables are coming from demographics domain. And then we have treatment duration variable, which is total treatment duration in days. So it says populate as the difference between TRT EDT minus TRT SDT plus 1. So we already have TRT, seen the derivation for TRT SDT and TRT EDT. So we'll have to make use of those variables and then create this TRT DURD. And then we have DT SDT, which is a numeric version of death date coming from SDTM DM domain. So which is DTH-DTC from SDTM-DM has to be used to create DTH-DT. And then we have two baseline variables, which is baseline height and baseline weight. So it says for baseline height, it says populate using VSSTRESN, where VSSCD is equal to height and VSBLFL is equal to Y. So we are making use of the baseline identification which has already been done in SDTM Vital Signs, and then we are using that record and the value from VSSTRESN to create height BL. Similarly, for weight BL, we will be making use of the record which corresponds to the VSSCD is equal to weight. This is how the specification has to be read and interpreted. Now we will move to the programming. So let's move to the programming. So what I'll do here is, so I'll keep the program on the left hand side and I'll have my intermediate and input data sets that are used and all the intermediate data sets that are getting created here on the right hand side. So I'll use the full window scope whenever I feel that it will be beneficial if we see it in full screen mode. So let's now quickly go through the program in full screen mode to get an overview of what we are doing. So I have my data stored in another SAS file. So I am including that SAS program. So when I run that SAS program, all the input data sets that are required for this lesson will be executed. So we'll quickly go through the program flow. So it says merge DM and sub DM. So we are transposing sub DM datasets such that QNAMs become variable, and then we are creating variables that are directly based on input variables, and then we are processing disposition data for treatment and study status, and within which we are processing it for enrollment, randomization, end of treatment, end of study. So we have seen in the specification that different records contribute to different records from disposition dataset contribute to different variables. So like enrollment, end of study. So we are processing them separately here, and then baseline variables from vital signs. And then we are bringing disposition and vital signs related info into parent dataset, which is HDTM demographics dataset. And then we are creating variables or assigning variables which are dependent on other variables. And then finally, we are keeping only the required variables. So let us now move to the program explanation. So we have seen that there are some variables which are required from supplementary demographics domain, so which contributes to certain variables in ADSL. So for that we need to fetch the information from the supplementary domain into parent dataset. For that reason, so we are merging demographics dataset and supplementary demographics dataset. But we know that in supplementary demographics dataset, we will have each of those additional variables in the form of rows, but we need them as columns here. So for that, we need to first transpose the supplementary domain such that each individual QNAM will become a variable, and then we will have to merge it. So for that purpose, what we are doing here is we are transposing our supplementary demographics domain and then creating a dataset called subdm01. So here we are expecting a record for one record per study ID and usubj ID. So we are using the variable study ID and usubj ID on the by statement. As we want to name the newly created variables with the values present in QNAM variable, we are specifying it on ID statement. And so very few people use the ID label statement, but we want the labels also to be carried forward, which are present in Q label for the newly created variables with the values in QNAM variable. So we have a statement called ID label. So like how we name the newly created columns with the values present in a variable, so we can fetch the labels from a second variable. So here we have the labels associated with each of the QNAMs and QLabel variable. So we are making use of ID label statement, and the values that have to be transposed are present in the variable QVal. So let's try to quickly take a look at subdm dataset and then subdm01 dataset to understand why and how the input dataset looked like and how the output dataset looked like. So let me quickly open subdm dataset. Here if we see, so we have information for race 1, race 2, and race SP. So this information is present as rows here if we see. So for subject 1002, there is a race 1 and race 2 both populated with the values of Asian and American Indian or Alaskan Native. So but we want these race 1 and race 2 be appearing as columns in our ADSL. For that reason, so we need to transpose this structure. And at the time of transpose, we need the variable with the name of race 1 and race 2, and at the same time we want to fetch the labels associated with those variables which are present in Q label. So we are making use of QLabel. So let's take a quick look at subDM01 dataset and see how it looks like. So we'll have one record per study ID and use subj ID. So here we have one record per 1002 and one record per 1003. The information which was stored as rows is now appearing as columns. We have a column for race 1, column for race 2, and then column for race SP. So we will now need to merge this back to our demographics dataset so that all the information coming from demographics and supplementary domain is appearing as columns in one single dataset. So this is what we are doing here in the next step, which is where we are creating it as DM01, merge DM and then sub DM. So based on the values in study ID and use subj ID. So let's take a quick look at DM01. So as expected, we'll have all the variables which are present in DM, and then these three variables will be added for the subjects which have information here. So let's open DM01. So what I'm trying to look at is, so to see if the newly created variables are coming into this one, race 2 and race SP. So note that the temporary variables which are getting created in the transpose step are also carried forward. So we can drop these variables here using drop is equal to option like drop is equal to underscore name underscore and underscore label underscore. So but that's fine for now, so as it is not causing any harm so far. So we have all the variables coming from demographics and supplementary demographics domain in a single dataset, and that is DM01. So this is kind of becoming our base dataset for our ADSL. So all the information that will be added to this set of variables present in DM01. So now in the next step, so we are creating variables that are directly based on input variables. So we have seen that in some places where some of the variables are direct copies, or some of the cases we were asked to use the values present in some of the variables in demographics domain and create new variables. So we'll see those now. So we are as a first step, we have seen that planned arm and actual arm, we were creating it using the values of uh, ARM and ACT ARM variables from SDTMDM. So we are creating TRT01P, 01PN, 01AN, and 01A using the values present in ARM-CD and actual ARM-CD. So in the first step, we are creating planned ARM variables using the values present in ARM-CD. So in the specification, it was mentioned as ARM, but here I am using ARM-CD because uh, ARM-CD involves less typing, and ARM-CD and ARM will have 1:1 relationship. So again, if we want, we can make use of ARM variable itself here. So if ARM-CD is equal to PBO, so then we are assigning the text placebo to TRT01P, and then assigning a value of 1 for TRT01PN. So again, make a note that, so in the specification, these two variables had the same logic involved because we were supposed to assign the value of 1 when it is placebo. So I am deriving these two variables using do group processing because the input condition for assigning 1 or assigning 1 to TRT01PN and assigning placebo to the variable TRT01P is the same, which is ARMCD has to be PBO. So I am deriving two variables within the same, and by checking the condition only once. And then similarly, I am checking if armcd is equal to active, then assigning the value of active to TRT01P, and then assigning the value of 2 to TRT01PN. So if there are multiple variables which require the same condition to be checked for, so you can make use of do group processing to create those. So and similarly, I am creating actual arm CD variables dependent on actual arm CD. They are TRT01A and TRT01AN. So I am assigning 1 and 2 to TRT01AN if it is PBO and active, and then assigning the text of placebo when it is PBO for TRT01A, and then assigning the value of active in proper case to TRT01A when the actual arm CD is equal to active. So this is one set of variables which are directly dependent on the variables in SDTM DM domain. So make sure that you are using the transpose dataset as the base. So we are creating ADSL01 here. And then the second set of variables which are directly based on SDTM demographics domain are some date variables. So here we are doing some date conversions. So we have seen that TR01 SDT was dependent on RFX STDTC. So and then RFX ENDTC was used in TR01 EDT, and then RFICDT from RFICDTC, and LST ALVDT, which is date last known to be alive, from RFP and DTC. So in ADaM, so when we are creating numeric variant, so here we are making use of SDTM input dataset. All of these variables are coming from SDTM DM itself. So we are creating the numeric variants of it using these lines of code. So let's quickly try to understand one line of code for all of these because they share the same logic for these things. So we are checking if length of a particular date value is greater than or is equal to 10, because in SDTM the dates are collected in character format and they are in ISO 8601 notation. We have the dates organized in the form of 4-character year followed by a hyphen, and then 2-digit month followed by a hyphen, and followed by 2-digit day value. And if we also have time component collected, we separate the date component and time component with a T in between, and then present the time in hours, minutes, and seconds with separated with colon. So we can create numeric dates only when the date component is full. So which means that if the first 10 characters are present, and that generally correspond to the date value. So we are checking if at least 10 characters is present, and then using YYMMDD10.in format, we are converting those first 10 characters to uh, numeric value using input function. So if length of RFX HTDTC is greater than or is equal to 10, then TR01 SDT is equal to input of RFX HTDTC and then YYMMDD 10 dot. So we do not actually need to extract the first 10 characters, because when we say YYMMDD 10 dot, so the only first 10 characters would be read. So yeah, I might have written in some other places where I might have extracted the first 10 characters, or I might have written a piece of code which extracts the first word when T is delimiter using SAS. But again, so we can achieve the same end result using different approaches of code. Don't get confused. So the end result that we want is to extract the date component and then convert it into numeric values. So we are doing same processing for all other different variables which are directly coming from SDTM DM domain. And then we have seen that for TRT SDT, so it was direct copy of ADSL TR01 SDT. So we have created TR01 SDT and TR01 EDT, which were subsequently used for creation of TRT SDT and TRT EDT respectively. So the one thing that we have to make sure that even if the derivation even in the variable TRT SDT was appearing first in the specification order, but it was dependent on variables which are listed somewhere down the line. So but in the time of programming, we'll first have to create the variables which are becoming input and then use them in creating the variables required. So here we have seen one case wherein we are making use of TR01 SDT and TR01 EDT, creating first and then creating these two. And then as these are numeric date values, so I am assigning a value of date 9 to all of the date variables which I have just created. And then, so we have seen that there are some grouping variables which could be directly created based on the values present in, based on the values directly coming from variables in SDTM demographics dataset. So only we had one grouping variable as part of this specification, which is age group 1. So here we have age group 1. So we were asked to check whether age is less than 60, and we are also checking whether age is not missing, and then assigning the text of age less than 60 years. So we know that most of the variant, it's not most, so whenever we are creating numeric variants, we generally create it as a one-to-one relationship. So I am creating both age group 1 and age group 1n in the same step, because it shares the same underlying condition of age has to be less than 60. So I am creating age group 1 and 1n here, and by checking the conditions provided in the specification of less than 60 and greater than or is equal to 60 and assigning the relevant text here. So till this point, so we have made use of the existing variables in SDTM domain and then created the analysis variants of it. And then we are processing disposition dataset. So before that, let's take a look at our ADSL 01 dataset here and see how that looks like. So we have added some new variables. So let's scroll towards the right and then see how the newly created variables look like. So we have created 01P, 01A, so and 01PN, 01AN, 01STT, 01ADT, RFICDT, LST, so DTHDT, TRT-SDT, TRT-EDT, age group 1 and age group 1N. So if we are programming it live, so we'll make sure that whether these values are coming properly or not. If we will also examine the log if there are any issues and then make sure that and fix those things and then have these things ready for subsequent steps. And as part of the next step, we will be creating our variables which are coming from disposition dataset. So when trying to understand the specification, we have seen that different records are being used from disposition dataset for different variables. So we will try to use or create a separate dataset for each of the conditions. So the first thing was for enrollment. So we were asked to use the record DS term is equal to enrolled for enrollment date. So here we are filtering for DS term is equal to enrolled, and then we were asked to use the value present in DSSTDTC variable on that record for populating enrollment date. So I am subsetting the record for DS term is equal to enrolled and then converting the DSSTDTC value to numeric date value and storing it in enrldt variable, and then keeping only the required variables of study ID, usage ID, and enrollment date. Let's take a quick look at disposition dataset. Here, if we see, we have multiple records per subject and one record per each of the protocol milestone or disposition event. From this record, so we were asked to use only the records which have the value of enrolled in DS term. So if I filter, so we have these records. So we were asked to use the values from DSSTDTC variable to create enrollment date. So if we filter for enrolled, so it is expected that only one record is present for each subject. So we know that in ADSL it has to be only one record per subject. So at the time of specification writing, you will have to give clear instructions on how to identify a single record for each of the conditions that have to be checked for. So let's now take a quick look at ANRL01 and then see how it looks like. So here if we see, we have for each study ID and usage ID value. So we are now having the enrollment data available. So all we need to do is we need to make use of this information and pull it into our base dataset. So the base dataset, after we derived all the input variables, which are all the variables which are directly dependent on SDTM DM domain or sub DM, is ADSL 01. So from this point, our base dataset will become ADSL 01. So we now have just seen how enrollment dataset has been processed and it is stored, the results are stored in ENRL 01. Similarly, we are processing for randomization information. So let us see how the randomized this RAND 01 looks like. So we are filtering for records where DSD code is equal to randomized and then making use of DSSTDTC on that record to create RANDT and then keeping only the required variables. So let us take a look at RAND 01. So here if we see, so we have RANDT available. So here again it is RANDT is present in a standalone dataset. All we need to do in the subsequent step is to pull the information from this dataset by merging it to the base dataset. And then we have records related or the variables related to end of treatment. So here we are processing for end of treatment. So we have seen in the specification that for end of treatment, so we had to use the record which correspond to DSSCAT is equal to end of treatment. So we are subsetting the record from disposition which corresponds to end of treatment. And then so we have seen that there were two variables which were dependent on this one. end of treatment state, end of treatment record. The first one was EOT STT, so whether we need to populate it as discontinued or completed. So we were asked to use the variable DSD code to create EOT STT. So and we were asked to populate it as completed when DSD code is equal to completed. So we are assigning the text completed to EOT STT when DSD code is equal to completed on end of treatment record. Otherwise, if DSD code is not null, so we were asked to populate it as discontinued. So we are creating EOT STT is equal to discontinued. There was a second variable which was called DCT reason, which is discontinuation, a reason for discontinuation of treatment. So for that variable, we were asked to directly populate the value from DSD code when DSD code is not completed. So we are handling it as an else if. So whenever DSD code is not completed and if it is not null, the reason for discontinuation will be present in DSD code. The same is now being assigned to DCT res. And then we are also creating a temporary variable called in EOT because we had a condition to check for whether a subject has a record for end of treatment or not in disposition. So when we merge this dataset to our parent or the base dataset, so the value in EOT would be 1 for the subjects who have a record in EOT01. For all the other subjects who are present in base dataset but do not have a record in EOT01, that will be having a value of missing in EOT variable. So we will be making use of this logic to identify the subjects who do not have a record of end of treatment in disposition. So let us take a quick look at EOT01 and how this looks like. So we are expected to have one record per subject ID and then the variables EOT, STT, DCT, res and in EOT. So let's open this one. So here if we see, we have one record per subject ID who have a record for end of treatment and disposition. So we have EOT STT completed for two subjects and discontinued for two subjects. And reason for discontinuation has to be populated only when EOT STT is equal to discontinued. So we are having the variables kind of partially derived here. And then we have created this temporary variable called in EOT to identify in the next step whether the subject is coming from this dataset or not. So this variable will be used to identify or create the ongoing status for EOT STT. So now let us move on to the next step in the program flow. So here we are processing disposition dataset for end of study status. So again, we were asked to use the record which correspond to DSS cat is equal to end of study. So we are filtering that record and then we are creating end of study status variable and also a reason for discontinuation from study which is DCSRES. So EOCSTT is equal to completed when DSD code is equal to completed, whether if it is not completed and if it is not null. So we were asked to populate the text discontinued in EOSSTT. So we are assigning that and then DSS race is created. So when compared to EOT, which is end of treatment, so we had one additional variable which is related to end of study status. So we were asked to populate EOSDT using the value from DSSTDTC on the end of study status record. So I am making use of DSSTDTC on the end of study record and then creating EOSDT. So here I have kept only the required variables EOSSTT, DCSRES, EOSDT and in EOS. So let us take a look at the EOS01 dataset and how this looks like. So we have records for all the subjects who had end of study record and the variables EOSSTT, DCSRES, EOSDT. Similar to end of study, end of treatment processing, here I am creating a variable called in EOS and assigning a value of 1 to it. So to make use of to check whether a subject is coming from disposition end of study dataset or not. So now we are in the next step, we are processing for baseline variables from vital signs. So we were asked to use the values from VSSTRESN where VSBLFL is equal to Y. For height BL, we were asked to use the record from VSTestCD is equal to height, and for weight BL, we were asked to use the record from VSTestCD is equal to weight. So I am upfrontly like for both the height BL and weight BL. So we were asked to use the record from record where VSBLFL is equal to Y. So I am directly filtering it. And then for height, so I am checking for VSTCD is equal to height and then creating a dataset called height BL and outputting that record to a dataset called height BL. And then for weight BL, I am checking whether the VSTCD is equal to weight and then outputting the record to weight BL. So we've and I am renaming the VSSTRESN to height BL because we were asked to populate height BL using the value from VSSTRESN. So now that we have kept only the height related baseline records in height BL dataset, we can safely rename VSSTRESN as height BL. So this is how we have created the baseline variables of height and weight. So let us take a look at the vital signs first. And then, so here the first primary condition is to filter for VSBLFL is equal to Y. And then, so we will have records for multiple test series within which we want to check for height. So we will be using this set of records to create height BL. And for weight, so if we filter for weight, then we have records which will have to be used for weight BL creation. So using the information from this dataset, we have created two dataset, which is height BL and then weight BL. So now height BL and weight BL are sitting in their own standalone datasets. So we now need to fetch all the information which is coming from the disposition based datasets and the vital signs based dataset into our base dataset. So as discussed, so ADSL 01 is now becoming our base dataset. So which has information which is directly coming from SDTM datasets and which are directly dependent, which are analysis variables which are dependent on the variables coming from SDTM DM domain. So we will now in the next step merge all this enrollment dataset, randomization information, end of treatment information, end of study information, baseline height and baseline weight to our ADSL 01. So I am merging all of the information, these datasets into ADSL 01 and creating a new dataset called ADSL 02. So now let us take a look at ADSL 02 to see how the variables are populated. So if I remember correctly, so we had information till age group 1 in ADSL 01. So all these variables are coming now from these subsequent merge. So we are getting EOT STT and DCT rees, and in EOT from EOT 01 dataset, EOS STT, DCS rees and EOS DT, and in EOS from EOS 01, enrollment date from ENRL 01, RAND DT from RAND 01, height BL from height BL dataset and weight BL from weight BL dataset. So we have also kept only the required variables in each of these datasets so that the ADSL 02 dataset does not become cluttered. So it becomes easy to uh, see and understand the data values if we are processing this each of these individual datasets in this manner, or keep like use the required records, keep only derive the required variables and keep only the required variables. So now let's see how these variables are, what are we doing in the next step. So we now have kind of all the core information required in the ADSL 02 dataset. And then create variables or assign values to existing variables which are dependent on other variables. So we have seen in the specification that some variables, some input variables are dependent on other variables. So we are now creating the section for population flags. So for safety flag, we were asked to check whether TRT SDT was not null, and if it is the case, so we were asked to populate it as Y. So if TRT SDT is not is equal to missing, then safety flag is equal to Y. Otherwise, we are assigning the value of N to it. And then randomization date not is equal to missing, then randfl is equal to Y, otherwise N. So we didn't have randt as part of our directly from either from DM or sub DM. So we can only create randfl once we had that randt fetched into our base dataset. So the rand information for randt was of course present in our disposition dataset. We have processed that and we have fetched that into our base dataset and then checking for the condition and then creating the flag of randfl is equal to y and then n. So in the next step, what we are doing is similarly we are creating enrollment flag. So which was the condition was to check for non-missing enrollment date and then flag as y if it is the case. Otherwise, we were asked to populate it as n. So we had one additional variable which was completers flag. So we were asked to populate it as y when end of study status is completed. Otherwise, it has to be n. So we are creating the population flags here. And then we have treatments and study status for ongoing. So if EOT STT is equal to missing, so here we have fetched EOT STT and EOS STT. But here now we only had the information which is related to completed or discontinued, but we also need to populate the information for ongoing. So what we are doing here is, so if existing EOT STT is missing and missing of in EOT, what does this mean? So we have seen that for all the subjects who are present in EOT01 dataset, the value in EOT variable would become 1 because we have assigned a value of 1 to that. So if we now see, so for the record subjects who had a record in a disposition with DSSCAT is equal to end of treatment, so we will have the NEOT value of 1. For all the subjects where it is missing, it indicates that the subject did not have an end of treatment status record. So if end of treatment status is missing and there is no record for that subject, so we are, and the subject is a treated subject, then we are assigning EOT STT is equal to ongoing. So this is what was the specification. If there is no record in EO disposition with end of treatment status, so which is so we are checking for the absence of a record by making use of the temporary variable which we created when creating the EOT01 dataset and then assigning the value of this one. Similarly, we are handling it for EOS STT as well, checking whether the existing EOS STT is missing and absence of a record in disposition with SCAT is equal to end of study, which is missing of in EOS. In EOS will be having a value of 1 when there is a record in disposition with end of study in DSSCAT. And then we are also checking for if arm is equal not is equal to screen failure and then assigning the value of ongoing to EOS STT. So this is kind of like we have partially derived the variable when processing the disposition dataset and then completing the derivation for that variable here. So you may want to, if you do not want to rename the existing variable, so you can just create it with some other variables like EOT STT pre or something when creating it and then complete the derivation of EOT STT here. But again, so the overall logic is the same. So some information could be derived and some information could be dependent on other cases. So we will have to process the code accordingly. And then we had the variable which was TRT-DURD. So here we need a TRT-EDT and TRT-SDT. So for calculating or deriving this variable, so which is TRT-EDT minus TRT-SDT plus 1. So we are doing that and when both of those variables are populated. So this information could in fact be derived as part of ADSL01 itself because all the variables which was needed for this derivation was present in ADSL01 itself. And then in the next step, we are keeping only the required variables and we are making use of the retain statement to order the variables in the required fashion. Let us now take a look at the final ADSL dataset here on the right hand side and how that looked like. So we have now our ADSL dataset with information required for all of the variables specified in the specification. So this is how you can program your ADSL dataset. Thank you for watching and keep learning.